Okay, good morning, everybody. This is going to be the first presenter interrogation session of the second day of Forest Genetics 2021. My name's Ian, and we're going to be talking to Anoob, Roos, and Brandon about their presentations from Climate Change and Adaptation 3. If you could put your questions in the chat on this Zoom call, that'd be great. And if we don't get to everybody's questions at the end, please feel free to contact the presenters directly. First question up is for Brandon from Emily Shoemaker, Morton Arboretum. Brandon, what management applications would you recommend with your findings? Assisted migration into suitable habitats, possibly? Question mark.
I think it's a good first step, but with these genetic offset methods, even though I can find a relationship between common garden performance and that genetic offset measure, even the strongest genetic offset measure, it's hard to say if that's something worth worrying about. And so there's other methods. There's another like forecasting method called GDM that will give me a value that's more something like FST. And so that's a little bit more interpretable, okay, which I haven't done yet. But I think, this is a first step to kind of see which populations might be the most vulnerable. And then I think more follow-up is necessary after that. I think this is a good first step to kind of see where everything is at and the state of things, and maybe prioritize different areas for a closer look. But I don't think by any means that this type of genetic analysis is the last step that should be taken to put into management.
Okay, Victoria Salk's got a question there that kind of follows on from that. Do you think SNPs alone could be used to select seeds for planting?
Well, that maybe that could, if you're talking about, especially if you had the genotype-phenotype relationship, and you knew, the phenotypes that were very important to growing in an area, and you could do a really good job of predicting that phenotype with a bunch of SNPs, then maybe yeah. We have climate SNPs, and maybe those are just as important. But it's hard to say what phenotype will come of the climate adapted SNPs, and I think it'd be a little bit more easier just to say, use the phenotype related SNPs to then think about, that type of phenotype score or that kind of outcome. Okay,
cool. Thank you. Let's move on to a question for Roos. It's one I've got that I thought was kind of interesting coming out of your work. Do you think there's potential to identify genetic invariants associated with clonality from the Aspen data?
That's a really interesting aspect. I think it would be possible because we see this like more prevalence of clonal populations in these dry environments. But I'm not fully sure until what extent my data could do this, because we have this like difference in sampling strategy that I mentioned earlier. Okay. So in Mexican populations, we did way more dense sampling in a small space than, for instance, in the northern population. So I think that would like introduce a bias, which might be like difficult to really like find signatures of this.
Maybe, but if you used population structure correction, it should potentially eliminate some of that and focus on the variation among individuals.
Yeah, that's a good point. That's I hadn't thought about it, but I will definitely take this into account. Thanks.
My thought was, because you've got multiple individuals per unique genotype, you could use the number of clones per genotype as your actual phenotypic score that you would then use for association.
Yeah. Okay, that's a good point.
Cool. There was a question for Anoob. What was the seed material? Was the seed material newly collected, and how many populations and families were sampled?
So we collected close to 340 families and encompassing 65 populations, and we collected it across the whole range of West Roos. And we also divided it into like geogenetic regions, wherein the seed sources corresponded with being core, margin, and edge, showing exactly how the range is distributed and how each family and population responds to that fragmentation, sort of, yeah.
Okay, I have a follow-up question for you as well. Thinking about the trial design and stuff, this was a seedling trial, or was it how old were the trees?
So they were grown in the greenhouse for about a year, and then they were transferred over to the common gardens at 3 sites: Vermont, Maryland, and North Carolina. So like 2.5 years old, like birth of that asset. Okay. So mostly initial growing period.
So one of the interesting patterns I noticed in your data for bud set in 2019 and 2020 was that there seemed to be relatively little variation in the Maryland population among individuals in the Maryland population relative to the Vermont and the North Carolina populations. There was that narrowing distributions. Do you have any ideas why that might be, either in terms of experimentally or in terms of adaptation?
Yeah, we think that maybe Maryland garden is like more closely representative of what the environment they were growing in. But then we looked at the transfer distance and the home garden for most of the, like almost 99% of the individuals were Vermont garden site and not Maryland garden site. So I don't know, but I would assume, but the transfer distance was basically based just on the mean annual temperature. So climatically, Maryland garden might be a better site suitable for red spruce right now. That's my understanding. Yeah.
Okay, that's good. Thank you. It's good to think about those kind of patterns. Next question is for Brandon from Jean Busquet. The zone of large genetic offset seems to correspond to a zone of introgression reported between the two varieties that he identified 10 years ago, where mitochondrial DNA was evident in central BC. Did you look at this with your SNPs and how steep the introgression climb could be, thus disentangling gene flow from adaptation in this zone?
So we do know. So yeah, that pattern was stuck out to me too. Let me first say that I want to make sure everybody realizes that I did those models separately for each variety, so that so that's not really anything like a bleed over of some of the information that's only in the coastal populations. So yeah, I think that's definitely a sign of that introgression zone. And actually, from stuff that I didn't have time to talk about with our GEA, with our bypass stuff, we found like 1,600 SNPs that are really high LD, and with little evidence of mitochondrial contamination. And so we think there's also something going on there, which might be some type of inversion. So we're going to explore that with some linkage maps. Where did that question go? How steep the increase? So introgression, disentangled gene flow from adaptive variation in this zone. I think given how long they've been, that those populations have been there, it'd be really hard to disentangle. Well, I guess the old adaptive variation from gene flow, but with our pool-seq data, it's going to be a little bit hard to identify that introgression in the same ways that we would be able to with individual sequence data. But I am thinking about some creative tests with like F3 and D4 statistics that we might be able to pick out some of those a little bit more clearly.
Okay, thanks. Let's look. For Roos from Seaman Nedo in Natural Resources Canada. Have you looked at signatures of local adaptation to dry environment? This should also be linked to clonality, I understand.
For Roos. That's currently actually what I'm working on now. So our next step is to look for the correlation with climate variables and look at genotype environment interaction.
Okay. What else have we got? Let's find, I guess, another question for Brandon then, from Mitra Menon. She was wondering, Mitra was wondering if you had given some thought to using a proxy for gene flow as a covariant in your gradient forest model. And it seems that larger populations experiencing less drift tend to have lower offset because of the low level of turnover.
No, I pretty much ran it the way everybody's been running it in the past, but I'm talking with Katie about some of our data and those steps moving forward.
Okay. And I guess a follow-up question from Stephen Keller. He's curious if you have compared your growth versus genetic offset correlations to a correlation between growth and climate variables.
No, not yet. But that's one of the exploratory things we're going to do soon.
Okay. Where do we go? All right. Just a quick question, I guess, again for Brandon. Did you control for or estimate the effects of other than climatic factors in your functions, such as soil conditions, etc.?
We didn't. It's my understanding that a lot of the soil, especially in Canadian regions, are a majority of one type of parent type of material. So we didn't factor that in. I think in other systems, it's important to factor in the soil types, but from what I've heard from the folks up here, that's less of an issue.
Yeah, I'd agree with that. And especially with the climate estimations as well, being estimators being so related to the soil types, that I think it's probably covered quite well. From Victoria Salk, again for Brandon. What if you don't have phenotypes? I think this is referring back to an earlier question about the genotype environment associations. Is there an option?
Yeah, so I was kind of thinking more about Victoria's first question. Do I think that SNPs alone can be used to select seeds for planting? And actually, they might be able to. And I think Ewa actually had a talk from her gradient forest using that application from on lodgepole pine and how well some of the offset PC groups matched up with the breeding zone. So, if you lack that previous breeding zone information, it'd be hard to say, and then you probably need some trials to validate that. But I think SNPs probably actually could be used towards that. And so, what if we don't have phenotypes? Is there an option? And so that's kind of like the grand question for these conservation efforts, isn't it? It's like, where do I put my money in? And then, how much bang for the buck am I going to get? And what I think about is, it really depends on where those limits really start constraining the type of data that you can collect. As once you reach an ending point, that's as much information as you're going to have to make a decision, and then that's kind of what you're stuck with. But I think if you have climate data alone, I mean, that's the first step. Colin Mahoney in our paper showed that climate data alone is pretty good, especially if you think that the populations have a good chance of being locally adapted to climate. And so it's kind of just building on the information that you have. I think you're kind of just stuck with what you're able to collect, and then make the best decisions from there. And then if you're able to do outplanting validation type things, then that's probably a good idea. But if there's not time or resources, you can't.
Okay. Cool, thank you. We'll take one last question from Stephen Keller in the chat for Roos. He observes that there's a really similar pattern of northeastern versus northwestern genetic clusters in populous balsamifera. he's dated the timing of that divergence to about 5,000 years ago, so post last glacial maximum. Do you have any preliminary evidence of an older divergence in Populus tremuloides?
I don't have any preliminary results myself. I know there's been other studies that looked at this, but I wouldn't know out of the top of my head what was exactly the divergence time.
Okay, maybe something to include in the future too.
Yeah, thanks.
Okay, thank you to all our speakers, Anoob, Roos, and Brandon. We'll now sign off, and yeah, please follow up with additional questions to them directly if you have them. Thank you.